With our curious childlike eyes, let us look at a plane that is flying in the sky. So this plane is flying like this in the sky. So as the plane is flying in the forward direction, what is happening with the air around the plane? So let me draw the air in yellow. From the upper part of the plane, the air is essentially moving like so. This is how the air is moving. And from the lower portion of the plane, I'll draw the air there in green. So the lower portion of the plane, air is essentially moving like so. So here it goes. This is how the air is moving from the lower portion of the plane. Now it is visually apparent that the air that is below the plane has a lesser distance to travel compared to the air that is above the plane. The shapes of aeroplanes are designed in such a manner. So naturally, the velocity of air above, V above, is going to be higher or greater in magnitude, and the velocity of air below is going to be lower in magnitude. Now, if we do take into consideration the ground level is going to be far below the level at which the plane is flying. Meaning, in other words, the height of the plane from a point that is below the plane to the ground level, or the height of a point that is above the plane to the ground level, okay, these two heights are approximately going to be the same, and hence there is not going to be any difference in the Bernoulli equation as far as the heights are concerned. So the difference is going to be caused because of the velocity difference as far as airflow is concerned. Now let us understand that when velocity above is greater, then pressure above the plane is going to be lower in magnitude, because the summation of half rho v square and p is going to be constant, since there is hardly any gravitational change in potential energy contribution in this particular equation. So what do I mean by that? We understand that by Bernoulli's equation, half rho v above square, okay, plus p above, this is going to be equal to half rho v below square plus p below. Now v above is much greater than v below, therefore the pressure p below is going to be higher in magnitude compared to the pressure above. The pressure below the plane is going to be much higher in magnitude compared to the pressure above the plane. So because of this, there is going to be a net upward thrust force that the air molecules will apply onto the plane from beneath the plane. So I am drawing this thrust force like so. So this is the thrust force that the molecules of air below are going to essentially throw up on the plane. This force that arises because of pressure difference helps in keeping the plane airborne. There is another drag force as well, but this force called as the force of airlift. Okay, this force is called as the force of airlift. So the force of airlift is nothing but the pressure difference, which is P below minus P above, into the effective area. So this force does help the plane in staying airborne, and this force is called as the force of airlift. Alright, so this is the aerodynamics of the plane, which we can simplistically analyze and understand vis-a-vis the Bernoulli's theorem.